very much. So today I'll be presenting on our team's project, Smart Manufacturing, Non-Intrusive Predictive Maintenance and also Industrial Monitoring. So our team comprises of 5 students from the University of Science Malaysia, Electrical and Electronics School of Engineering. Right, so where are we headed? Our mission is to transform industrial approach and operations from the conventional method to a more advanced sensor, real-time analytics, also non-intrusive approach. So for our objectives, we have 3. First is to provide a more advanced and accurate monitoring system. Next is to accurately detect the start tool failure or machine failure. And lastly is our non-intrusive predictive maintenance, which is considered as a plug-and-play system for any kind of architecture. Okay, so what's so special about our system? Firstly, we have our machine learning implementation, which acts as a prediction for our maintenance. Next, we have our non-intrusive monitoring, which ideally means it's plug-and-play, means it can be used for any architecture. Then next we have our interactive dashboard and also 3D modeling, where we depict our physical system into a digitally, which portrays our physical system. And then lastly is our automated alerts in the form of emails. Alright, so for our methodology, we have 4 subsystems total. So our first subsystem is our raw monitoring system, where we take data straight as it is and display it on our dashboard. So we have 3 sensors for this: the pressure sensor, the proximity sensor, as well as the tower light sensor. So this is fed into our data acquisition modules, the WISE modules, and it is sent via our industrial gateway to our dashboard. Alright, so for our first predictive maintenance system, for our actuator, we have our magnetic switch on our actuator which sends data in the form of timing variable to our dashboard. Okay, so now for our second predictive maintenance system, we are going deeper into our motor. So we have 4 sensors that we use. First is our encoder, we have our smoke sensor, we have our vibration sensor, and lastly our temperature and humidity sensor. So these sensors send data into our data acquisition modules, the Raspberry Pi and our WISE module, and from there to our industrial gateway, it is sent to our dashboard to be displayed. Okay, so the highlight of our system here is our machine learning implementation, where we have trained an AI model with about 1,000 data sets. So this model is used where we feed our motor monitoring parameters and we obtain a prediction for our motor health from there. Okay, so our results, first we have managed to do a 3D modeling of our system. And then secondly, we have our monitoring system, raw monitoring system, where data from our sensors is accurately displayed on our dashboard. Alright, so for our first predictive maintenance system, the data from our actuator is displayed as a graph with a threshold on our dashboard. And lastly, for our predictive maintenance, which is for our motor, we have the our 5 details, which is the temperature, humidity, vibration, RPM, and smoke detected, which is displayed on our dashboard. Alright, so the change in our predictive maintenance is captured in the form of notification and sent to email. Okay, lastly, for our machine learning implementation, I could say with about 98% accuracy, we are able to accurately detect the motor health, future motor health. Alright, so next let's move into our demo for our system. So our proposed solution, non-intrusive predictive maintenance and monitoring system, where we have our 3D modeling and dashboard which are linked to all our real-time features. Next, we have our counter for non-metal and metal, which are synced to our dashboard in the form of numerical values. And for our timing variable, so next we have our multiple sensors for our motor which predict the motor health, and we have done more tests in our USM lab to accurately predict this. So next, for our vibration and speed of the motor, we implement this to predict our motor health as well. And then for our timing for our actuator works well, where there's a threshold and also timing variable. Right, so next we have our MQ2 smoke sensor, which does smoke detection of our motor, and our temperature and humidity sensor, which sends data in the form of degrees Celsius and percentage. Alright, so for our notification, we push it all to our email in the form of examples like this. Alright, so the impact of our solution to correct maintenance is we are able to minimize unplanned downtime for 45 to 50%, extend asset lifespan of our machine by 20 to 40%, improve maintenance efficiency by reducing costs by 20 to 40%, enhance the safety by eliminating the need for manual inspections. By that, we are also increasing productivity by boosting production up to 3 to 5%, and lastly, we save costs by avoiding high repair. Alright, so that's all from me, and thank you for tuning in.